Hey everyone. So we're going to get started in a little bit. I'm going to put onto the screen right here the several problems that I was sent before today. So the first one is we have a language F right here, which is the set of all strings of the form. What is it? A to the I, B to the J, C to the K, such that if I is equal to 1, then J is equal to K. And what we have to show is, show F is not regular. So that's the first problem that we're going to tackle. If you have other problems you want to work on, put them over there. I'm watching the chat at the same time, even though it looks like I'm not. And 2 is, let's call this language P to be the set of all strings of balanced parentheses. If I can spell parentheses, that'd be good too. Parentheses. And the question here is to show P is not regular. Okay, and so that's what we're going to be tackling here today. If you have other questions of really any kind, put them over there. I'm watching the chat right now. Yeah, so these are the ones that I was sent on my Discord server. The link to the server is down below if you want to join and help solve problems with everyone else. We have quite a few people on there already, which is nice, and we've had some good discussions on a lot of things that are theory related, not so much on algorithms related. Maybe I'll add some text channels for discrete math and algorithms, so it's not all in one channel. That might be a good idea. Maybe I'll do that after this stream. All right. So we'll start in a few minutes here. I'll just advertise that we are streaming now. So let me go ahead and do that. Put it on all these social media sites. There probably is a way to advertise that you're streaming everywhere all at once without having to copy and paste it everywhere, but I like copying and pasting. And there's only a few sites, so it's not a big deal to me. All right, page. If it'll ever load. I don't want to do that. Post. All right, so then now let's post on Twitter. All right, so those are all set. All right, so we got these two problems right here. So we had some good discussion on the first one. I was just sent the second one. So the first one, I think, comes from the Sipser textbook. I'm not exactly 100% sure about that. Maybe someone should confirm that for me. But it's actually a really nice problem. So we'll solve that in a few. And the second one is, I may have done already. I'm not 100% sure. If I haven't, that's a shame. So let's see. I actually don't remember if I've done it all yet. Let's see. Maybe I have. No, I haven't. Okay. Which is kind of sad. All right. So we have these two problems. If you have other problems that you want to work on, and I'm sure some of you do, based on the number of questions that I get on the YouTube videos, but not explicit problems for me to go over, put them over there. So what I'm actually going to start doing, starting this week, is instead of just doing the series videos that I've been doing over and over, I'm going to have them be the same topics each day. So algorithms Monday, Tuesday, discrete math Wednesday, Thursday, theory Friday and Saturday. But I'm going to put some notable exam problems on each of on some of those days. So it's not like just all straight topical stuff. It's going to do some actual problem solving, which I think will be pretty fun to do. Okay. So let's see. Yeah, so there's one that's coming out on Wednesday, specifically related to that. Let me actually look. Yeah, I think it's on discrete math, but I'll check again. I'm doing so many videos now, I don't even remember which one I did. Yeah, okay. So I actually, yeah, so it's that one happens to be a gate problem that I'm going over, which is on Wednesday. So Wednesday you'll see that. I've actually just created several playlists on the channel about these gate problems and organizing them by year as well. So I'll actually copy and paste them into the chat. Let me get to it in a second. So that the one I just posted is for all gate problems in my entire channel, but I have two more, at least for now, that go over, that have some problems from 2019 and 2020. And I know I've done every single gate problem already, but I think it'd be a better idea to do each individual problem instead of just a one huge long video. I think that would actually be productive for a lot of you. So I have them organized into individual playlists, and you can go by which question that you're interested in. So I have that there. All right, not many viewers today. So maybe, depending on the number of viewers we get, we may just do these two problems and that's it, but we'll see. Yeah, if any of you who are watching have any questions or problems that you want to solve, put them over there. I'm watching the chat. Please don't send me homework problems that you're working on. We've had that several times in the Discord server. Please don't do that. We're not here to solve your homework problems for you. That's for you to do. We could give you the ideas of how to solve them, but we're not going to solve them for you. So just a word of warning to anyone who's watching. All right. So so for these two problems, we might as well get started because I'm not seeing any additional questions. So for these two problems, we're showing that they're both not regular. So obviously a good technique here is to use the pumping lemma, okay, or use the pumping technique. You could use something like the Myhill-Nerode theorem, equivalence relation, but I think that's a little too much firepower for these. Pumping lemma is just good enough for our purposes. All right, so feel free to put your strategies into the chat as well. So for this first one right here, using the pumping lemma straight away will not work ever. Okay, so why will using the pumping lemma straightforwardly will not work in the usual sense? So why would it not work? So let's actually what I'll do is I will do this. I will move this question down, or at least I'll cut it down. I'll paste it way down here, just in case that we need a lot of room for this one. Okay, so what we have here is we have a language right here. So the usual way of proving this, so this is not of the actual proof, is just a potential way that you would approach this type of thing. So we want to show it's not regular, so let's suppose it is instead. So suppose f is in fact regular, then everything that we've done so far about the pumping lemma, you should know that there exists a pumping constant p for that language f. So then what do we do here? We pick a string of length at least this long, and it's in this language. So one possible string that you could pick here is, let's choose the string w to be a, b to the p, c to the p. So the language says if the number of a's is 1, so there's only one a, then the number of b's and c's is the same. So that's what this is saying here. So if I don't pick exactly one a, then the number of b's and c's can be anything, and that's not going to ever help us. So I actually will claim that using the pumping lemma directly will not work in this case. Why will it not work? So if we look at this and we say, okay, well, I gotta look at every possible decomposition of this string into 3 pieces where x and y have at most p characters, so that means they're only in the a's and b's, because we have a run of p b's here. And yeah, so then if we can show for every possible decomposition we can leave the language, then we're good. So let's look at one decomposition. So if I pick this decomposition, so if I have that the x part of the string is empty, y is a single a, and z is the rest of the thing, then let's look at what the string, what the string x, y to the I, z is. Because we have to show that for some value of I, we will leave the language. Well then, if you just do a routine computation, what you get is a to the I, b to the p, c to the p. And then we notice up here that the only possibility of this string not being in the language is if I is equal to 1. But when I was equal to 1, that string was in the language because that's what we picked it to be. So in the number of b's and c's never changes because the y part only hits the a's. And so for that reason, this decomposition, no matter which choice of I we pick, this decomposition will stay in the language no matter what. So this thing will stay in the language no matter what. So we can't possibly pick this string because one decomposition at least will cause this thing to stay in the language no matter what. And in fact, if you pick anything other than this, then the number of a's will not be the same. I'm sorry, the number of a's won't be 1 because that's what this says here. And then as long as the string has a's, b's, and c's in it, then that's all we need. So this is actually a quick summary that the pumping lemma directly will not ever work. But there is a different technique that will work. So it's to note that, well, we know one of the most infamous non-regular languages is, I'm going to phrase it this way, c to the n, b to the n, where n is at least 0. So this guy is not regular. Well, it kind of looks like this, in the sense that when a is equal to 1, the number of a's is 1, then we have effectively b to the n, c to the n, because the number of b's and c's is the same. So if we can somehow, so the problem is that the x and the y part are at the beginning of the string, whereas the part that involves the b's and c's here are at the end of the string. So wouldn't it be nice if we can just take all the strings in the language and then just rotate them to be backwards? So that's actually one of the important things here, is that regular languages are closed under reversal. And I don't want me to just be telling you the solution, although I will. I want this to be kind of collaborative, so if you have any questions or have any other problems you want to work on, put them into the chat. I'm watching the chat for anyone who's watching. So regular languages are closed into reversal. So if you don't remember, the reversal language of, so let A be a language. The reverse of the language, which I'm going to call A carry R, what that language is all the reverse, so take all the strings in the language and reverse all of them. So if we have, and how do we define this? So W to the R is going to be Wn down to W1 if the string originally W was W1 to Wn. So it's just writing the string instead of from 1 to n is going downward. And yeah, so here we're taking all the strings in the language and just flipping them around. Okay, so they're closed under reversal. So that's actually not that interesting. What's interesting is that, actually it is kind of interesting for our purposes. So this tells us that if we look at the language F to the R, where F was the original language, that's what it was called before. So I'm going to look at the strings of the form C to the K, B to the J, and A to the I. So it's just flipping them around, where if I is equal to 1, then J is equal to K. Same condition as before, no different. But now, if we pick the string, so if we pick W to be C to the N, actually P, B to the P, and then a single A, then we're back to the A to the N, B to the N condition. So like the same number of characters at the beginning. So then what we notice here is that the X and the Y part are all within the run of C's right here. And this will pump out of the language F to the R this time, because the number of A's doesn't change. It can't possibly change because the X and Y part, the Y part is the thing that you're putting more of into the string, and they don't ever even touch the B's, let alone the A on the outside right here. And so this A is kind of the key of the first two pieces having to be exactly the same number of characters each. And by moving it over here, we can guarantee that it'll never ever be modified, no matter what the decomposition is, into 3 pieces. Or at least according to the rules, the 3 pieces. Okay. So that's just kind of a hand-wavy proof. I could make it more formal than this, but this is just the basic idea. Okay. I don't see any questions. So what questions do you guys have? What other problems do you want to work on? How's your semester all going, by the way? Hopefully everyone's doing well, despite everything that's happened. Um, so this was just it is a standard pumping lemma style proof, but you need to make that observation at the beginning that the A part has to be at the very end. And you actually could, so there's another way you can do this, I just realized. So what you could do is, what you could do is take f to the, let's see. Yeah, I think you can do this. So I think you could take f, the original language, and intersect it with A, B star, C star. And so that will be all the languages, the strings that will come out will be A, B to the n, C to the n, where n is at least 0. And I think that'll be a lot easier to prove. Yeah, this would work. So we don't know, or we haven't proved, so we don't know if regular or not. So this one right here is definitely regular, for sure. And this one over here is actually not that hard to prove is not regular. And you can do because it's effectively just putting an A on the front of a non-regular language, and that's not going to change anything, at least in this case. So here, let's look at this. So if this guy was regular, then closure under intersection would tell that this guy over here is regular, but we know it's not. So we can actually, I'll do it this way. So we can deduce from this that f is not regular from this. So, yeah, that's another way you can go. So you don't have to do a perfect pumping lemma argument. You can use closure properties here, like we are here. So this was closure under intersection. So closure under intersection. Okay. All right. What other questions do you guys have? Oh, one thing I should mention is that we did hit the 4,000 hour mark for requirements for monetization on YouTube. One of the things that so ads haven't appeared on the videos yet, and that's primarily because for some reason now each channel has to be manually approved for monetization purposes, and they say that that can take up to a month. So, yeah, so it's not quite there yet. But yeah, so everything is set up. They're just reviewing it now. Everything should be good because there is no copyright strikes or anything, so I should be in the clear. But it's just gotta wait for it, sadly. All right, and yeah, and the growth of the channel has been slow but steady. If you have email, I can send you my homework if you can help me solve it. Really? No, I'm not going to help you do your homework for you. I can help you with the ideas. You can definitely do that, and my email's in the video description, but I'm not going to solve your homework for you. I may give you some ideas or tips or things, but I'm not going to solve it for you. That's not what this channel's for. Channel has been a big help, dude. You're absolutely welcome. Grapple stuff? Do you grapple stuff? All right. Yeah, what other problems do you want to work on? We have that second one, but I'd rather do the problems for the people who are actually watching this live, which I think would be the most helpful. This course is hard for me. So I've taught roughly like over 1,000 students in some form or another for this class, and not one of them has ever said it was easy. So if you're not struggling, you're doing it wrong, or you're not working hard enough, or you may be a genius, but for the vast majority of people, it's difficult. It was difficult for me. Just putting that out there. All right. What other questions you guys got? So because we hit the 4,000 hour mark, I'm not as focused on I'm not focused on the amount of time people watch videos, although that is important. I'm focused more on the number of views at this point. Yeah, so it's actually more equal focused. Because before, the requirement for monetization had nothing to do with the number of views. Whereas now, when I'm going to start monetizing things, the amount of money that comes through to help support the channel is based on the number of views, and technically the view time also, because the amount of times that YouTube suggests my videos to other people is based on a number of factors, including how long people actually watch things. So, and the number of views too, but a whole bunch of things. Yeah, so this video will be so all the live stuff will be uploaded. Everything's in a playlist. So I have a whole load of playlists for any type of thing that you're interested in. So solving problems, or the ones that I do live, or gate questions, or other exam questions, or conceptual stuff. Everything of all kinds is on my channel. I probably need to organize the playlist better, but everything is all there in playlists. Yep. All right. So maybe let's look at this one. Although this one is actually pretty I put it down here. Yeah, that's right. So let's move it up here. Your advice to better understand the course? Watch my videos. Yeah, not really. Although that a lot of people say that it helps to watch my videos, but yeah. So my recommendations are to understand the definitions really well. So understanding the definitions is your best friend. Another thing that I recommend is to look at problems that you've seen before and slightly modify them and see if you can actually still solve them. So like for this example right here, what if I said if I is equal to 1, then j is equal to k, same as before, or if k is equal to 1, then I is equal to j. So basically just adding another condition onto this. Does it become regular, or does it stay non-regular? Is it context-free, or does it become not context-free, or whatever? Okay, so it is taking problems that you're looking at and slightly modifying them, because that's what we theory professors like to do. Yeah, so I'm actually telling you the secret as someone who's taught this course many times. Look at problems that you've seen before and slightly modify them. and make sure you understand definitions because they're your friend. Cavalli, did you get the required video watching time for ads? Yep. So we hit it about 3 or 4 days ago or something, which is awesome. Yep. So we did make it. Ned passed the first theory test on Thursday with the channel's help for your information. Thank you very much. Let me know. So Ned, let me know which video was actually most helpful. Yeah, so that I know like which things to emphasize is probably the theory stuff, but no, not theory stuff. It's the pumping lemma stuff, but yeah, let me know what video was most helpful. Devanshu, how come you retracted all 3 of your messages? It's totally fine. I mean, I have thick skin. Oh, pumping lemma examples. Okay, yeah. So that one video has actually gotten considerable number of views compared to every other one, which is the one on the pumping lemma 4 proofs there. Yeah. So that one. So I'm actually looking at my videos right around each other, and the one right before it has like 100 views, then the one after is like 180, and that one has like almost 600. So that one's actually getting the second most number of views, I think, in the last like week, compared to the most popular one on the channel. So clearly that's a good thing. Actually, I guess having longer videos is a good idea because it appears that the longer videos are watched more and longer than any other one on average, which is good. So that might be something I'd look into. So there is a video coming this Friday that's an hour 22 long, so 82 minutes, and it's a first on YouTube. So watch out for it. It's gonna be a special one. Yeah, my midterm will be in pumping lemma, so any solving more problem on it is a good idea. Yeah. So the one that I just did is clearly a pumping lemma style proof. If you have particular types of problems that you want to do in pumping lemma type territory, then we can do those. You can suggest problems, and I can do a slight variant on them. So that's totally fine. I mean, I could do the balanced parentheses one, but that's effectively the A to the N, B to the N language proof of non-regularity. So there's nothing really inherently special about this language in terms of actually proving it to be not regular. So I have a whole bunch. So I actually have a whole playlist on my channel devoted entirely to pumping lemma style proofs. Okay, so abd I would check out that playlist because any and everything on the pumping lemma I have a whole playlist for. In fact, I'll share it with you. Let me find it. I have a ton of playlists. Yeah, here. Yeah, I'll put it right here. There. Yeah, so that playlist will help you. Let's see. Yeah, any other things you want to work on? Any other types of problems that you want to see? Thanks for watching. And thanks for everyone for being subscribers through everything that's happened in the world. It's really fantastic to see my channel grow so quickly. So like in the last month, so I'm looking at statistics now, my channel got like around 18,000 views in a month. And that's what my other channel where I had teaching stuff on it got in like a year at best. So yeah, so it's quite amazing what this channel has already gotten off to. We're very likely to hit 100K views before December even, I think. I was going to say the end of the year, but I think we can do it before December. So keep watching. Hopefully we can hit 100K views quickly. Do you make videos for discrete math? I absolutely do. So I have a whole series on my channel. I'm going to share the playlist with you on discrete math. So there you go. So that's discrete math stuff. So it's kind of barren right now, and there's not a lot there. I'll see what I can actually do with it, because there are gazillions of directions I can take discrete math in. There are many things that I can emphasize or not emphasize, or just do everything, or it just really depends on what you all want to see. But I have all the basic stuff there. So like proof strategies and what logical equivalences and all that stuff. So that's all there. Okay. Yeah, so I do algorithms, discrete math, and theory of computation for now. There are some other theory stuff that I eventually want to get into, but those three are the main three for now, at least. Because that's what most people are interested in and most likely to watch. They're probably not going to watch things on category theory, although there may be some people who do, but not many people are taking classes in that, and so won't be interested. They want to see discrete math, algorithms, and in theory stuff. All right, what problems do you want to work on? So this one I'm not going to do because this one's effectively a to the n, b to the n. It's not exactly the same. Actually, one way you can actually show that it is kind of the same in terms of regularity is that you can do p intersection with the left parenthesis star, right parenthesis star. And so this one is equal to left to the n, right to the n, where n is at least 0. And you can see that these are obviously the same. Yeah. And there's one way you can get this, that there's a homomorphism from this language to this one. You don't have to know what that is, but effectively they're the same. And so this one is regular, this one isn't, because it's the same as this. And so this one can't be regular. Yes. We can use a stack push, left, pop, right. Yeah. So it is a deterministic context-free language, but that has no bearing on whether it's regular or not. So a language could be regular and a DCFL at the same time. So this question I get all the time, which is that how do regular and deterministic context-free languages relate to each other? They relate to each other like this. So every regular language is a deterministic context-free one, which is already a context-free one. And this is the case because a deterministic machine for a context-free language doesn't have to use the stack if it doesn't want to, and so it can behave like a NFA or a DFA. It doesn't really matter. So this a machine here can simulate anything in here, and so therefore every regular language is deterministic context free. And this inclusion right here is pretty obvious too. in terms of them being strict, well, a language like the empty set is clearly regular. Something that is DCFL and not regular is the A to the N, B to the N language. And actually balanced parentheses is too for a different reason. Yeah, so then for context-free, that is not deterministic context-free, this one's a little harder, but if you do A to the N, B to the N, C to the N, and take the complement of that whole thing, then that ends up actually being context-free. And we know it's not deterministic context-free because DCFLs are closed in their complement. That video will eventually arrive on my channel at some point. And that will also be a first on YouTube from what I can tell. And so the complement of this guy right here is not even context-free, let alone deterministic context-free. And so therefore this guy can't be a DCFL. So that's one quick proof. And something that's outside here is, say, the original language, the one that's not complemented. And so that's out there. Yeah, so why do I bring this up? So if I give you an example of a language L that's right here, that is a DCFL, that doesn't immediately say, oh, it's not a regular language. Just because it lives in the DCFL bubble doesn't mean it can't go lower. If it's in here, it obviously can go up, but it doesn't mean that it can also go down, but it could also go down. So if L is the empty set, then it can go all the way down into the regular bubble, even if I already show it's a DCFL. Okay, so once I establish it someplace in the hierarchy, it's from there, it can go outward. So every DCFL is a CFL, which is decidable, etc. But it could very well go inward. Okay, that's like saying every language is decidable, and therefore it isn't regular. But that's clearly not true. So that's just something to keep in mind. I'm not picking on you. It's just something to keep in mind. Okay. All right. What questions do you guys got? Getting some more viewers now, which is good. What other questions you guys got? Let's see. And if all of you could recommend this channel to anyone who's taking this class, I would highly appreciate it. I can never have enough viewers, enough subscribers. So although the channel is actually doing pretty well the last few weeks, I'd rather, of course, see it continue to go up. But if you can all recommend this to any of your friends or family members who happen to be interested in this type of thing or are taking a class in it, I would really appreciate that. Well, okay, let's see. So we could do some gate problems. I think that'd be interesting. So gotta put CS in. If you actually, or at least this only works for me, if you Google gate theory problems CS, then actually my video comes up first. Yeah. What about gate theory CS? Oh, if you Google gate theory CS, it's first. At least for me, it is. Oh, that's kind of cool. But let's look at a certain set of problems. So maybe let's look at 2020 problems. That's not what I want. I want to look at previous exams. That's not helpful. I saw them earlier today. How come I can't find them? Okay, maybe this. Okay, maybe 2020 is not available. So let's see. Oh, well, of course it's not there. Jesus, let me find this. Maybe this. Okay, so let me fix this so that you can all see. That's not what I want. Window capture. Select option. Okay, so maybe this will work. Let's copy this over. Hopefully this works. Boom, let's see. Okay, so yeah, that kind of worked. Hopefully. All right, so let's scroll down here and see. So I've done some of these on the channel already, so I'm not going to do them over again. Yeah, so like this 8 question right here, the question number 8 is really 18 because there were 10 before in the previous section. So I did that one on the channel already, so I'm not going to do that again. Yeah, so I'm not 100% sure about what LLK is. I've seen it before, but it's not something I'm familiar with, so I'm not going to answer that one. So let's see, are there any other theory ones? Yeah, so this 26 I've done already on the channel. Okay, 32 I don't think I've done before. Would you prove that, okay, so let me copy this question in and then I'll look at Ab's question. So let's see. So we have L1 being W, X, Y, X, where W, X, and Y are non-empty strings, and 0, 1 strings. And L2 is X, Y, such that X, Y are A's and B's, or some strings of A's and B's, and X is not equal to Y, and the length of X is equal to Y. And Ab's question is L is equal to B star, C star, union, A star, B. Okay, I think I got that all copied. So let me see if I can transition back. Boom. Hopefully that worked. All right, that's good. So I think I'll answer Ab's question first. So this one is regular. And we know it's regular because it's a regex. So this thing is a regex. Or maybe you intended you intended this to be a different language than this, but this language is regular, or at least how you wrote it is regular. If you meant something else, let me know. But the way that you wrote it is regular. All right. So this this first I should say that this is non-empty strings. So the plus up here means non-empty. The star, if I put a star there, that means empty. So this one's actually kind of tricky. So let's see if I can get this right. Sorry, I meant the second one. What do you mean by the second one? Do you mean A star B? Well, that's still a regex. Yeah, I'm not sure what you mean. So let's look at these right here. And I think the question said which of them is true, and it has several answers on whether they're regular and context free and whatnot. So let's see. Let's actually try to figure out what the answer is here. So this one was question 32. So 32. So this first one right here. So if we look at this right here, then we notice that the only things that are really troubling in some sense are the x and the y, the two x's right here. But notice that the w and the y right here are, yeah, so the w and the y are kind of free range, right? So that they can be effectively any string that they want. There's no constraint on what they can be other than non-empty, but that's not really an issue. So here, the x here, if I just set them to be a single character, then since the w and the y part can be effectively anything, then all that we're saying is that yeah, so each of the strings that you can actually form in this language have two of the same character at least. So in the case that x contains a 0, then this string is going to have two zeros in it. If it has a 1, then this thing has two ones in it. So every string in the language must have at least either two zeros or two ones or both. And they must be separated by at least one character. But there's, and also, yeah, and in fact, because the x is at the end, it actually doesn't matter. So every string, well, this thing has to be non-empty because of this condition here. So every string must end with something. So if it ends with a 0, then it must contain another 0. If it contains a 1, if this thing ends with a 1, then this thing contains a 1 earlier on. And it turns out that there are only finitely many possible strings that are, there are a regular language of strings that are excluded from this, or at least included. It doesn't matter which one of those you look at, because the description of what this language is you can effectively just restrict x to be a single character and let w and y let w and y be anything. So here, because they're single characters, you can actually just rewrite this language. If I'm not reading this wrong, you can write L1 as effectively being the same as 0, 1 plus. So this is for the W part. Then we have 0, 1. So we must have one of the two. And so that's for the X part. And then we have yet another 0, 1 plus. And so this is for the Y part. And we have another 0, 1 occurrence for the X right here. So it's not exactly this, because these two have to be exactly the same, but it's very close to being this. And so you could take this language and try to exclude some things from it. Meaning, like, if there's only zeros and this ends with a 1, then you just do intersection with the complement of that, which is regular, or if it was entirely ones and ends with a 0, then you intersect it with that, the complement of that, because we don't want those strings. And so from that you can actually show, because this thing is regular and you're intersecting it with two things that are also regular, then closure under intersection tells you that this is in fact regular. So that's actually a really long-winded proof to show that L1 is in fact regular. I send L equals after that. Sorry, I'm not sure what you're referring to. Note that, okay, so that's a different question. Would you prove that L is not regular, but what is L in this case? So if you have two different messages, what does the first L refer to? All right. So that was the first one. So then the second one, so what do we have here? Let me move this down carefully. So copy. So I'm going to move it down here where we have some room. Paste. So we have two pieces. X and Y are just A, B strings. They can be anything. Where X is not the same as Y, and they have the same number of characters in each. So you can actually infer from this that every string in L2 has even length. Okay, so what you can actually do, based on the intersection idea that we've done already several times today, is you can actually intersect this with, let's see, so with the language, let me phrase it this way, Z, where Z is in, so the length of Z is even. And we know that this thing is regular for sure. Yeah, so that thing is regular. So if L2 was regular, then the whole thing would be regular. So then what is the result of this? This is effectively the language above, but where they're not the same. So X, Y, such that X is not equal to Y. We know that they're A, B strings. I'm not going to repeat that part. Okay. Actually, no. That's not the best idea. Scratch that. Yeah. That idea didn't work because the resulting language didn't have any criteria about like the lengths of X and Y. So every string in here has even length for sure. So, what would you actually do to prove this? So, okay, yeah, this is actually really easy to show that it's not regular. So this thing is definitely not regular. And why is that? If we pick the string W to be A to the P, B to the P, then because of this condition over here, where the length of x is the same as y, then it must be the case that this part is the x part and this part is the y part. So this is something that a lot of students mess up, that like if you have multiple pieces and you write like a to the p, b to the p, then they mistakenly think that each of the x, y, whatever pieces are each of the runs here of the string, like the x is entirely a's. That's not necessarily true. But in this case, it has to be because the lengths are the same. So it must be that the x part must take all of the a's and y part takes all the b's. Can you cover all gate questions? I already have. Yeah, so let me actually, it's actually the most popular video on my channel, but I'll share the video with you. So let me share the video with you. There you go. Yeah, I solved them all before. So for this one right here, what we can do is, because we have the regular property, we're showing it's not regular. So that means that the part that's being pumped is in the A's part. So so pumping will, we'll give A to the P prime, B to the P, where P prime is not equal to P. Okay, yeah, because I'm putting either more A's or fewer A's in. So therefore, the number of A's that I get is not the same as the number of B's. And what we can actually, and clearly they weren't the same before. And what do we get here? Oh, actually, this won't leave the language. Okay, so that's not immediately obvious. Okay, yeah, that's not immediately obvious. Yeah, because here, what if the decomposition has an even number of characters? Then we're going to put an even number of A's in, or take out an even number of A's. So the resulting string will still have an even number of characters, but the number, but the strings definitely will still be different, because the y part will have at least one b, and the x part will definitely have one a, so they can't be the same. Actually, no, that's not a proof either. But okay, so let's scratch this. So that's not a proof. It is not regular though, but it's hard to actually prove this. Yeah, so it's actually context free, but I haven't gotten to that yet. Yeah, so it would be a context sensitive language. Yeah. I haven't gone over context sensitive stuff on the channel yet because I'm super sensitive. But let's try to prove that this isn't regular. So what would you do here? So the hard part is being able to, so you start off with the two parts not being the same, and you pump enough until they are the same. Yeah. So this might involve the P Factorial trick that I've talked about before. Although that seems a little, that seems a little difficult to prove. So it must be the case that they have a different set of characters. they can't be uniformly different. So one of the two strings here has to have both characters in it in order for this to even work. But the problem is that you would need to show this for every decomposition. So for every decomposition, you would need to find a value of I for which yeah. Would looking at the complement help? I thought this one was easy. I guess I forgot the proof of this one. Let's make sure I get the definition right. Yeah, so that's right. So x not equal to y. So this is actually, yeah, so this is context free. And the reason for that is the so they must differ in at least one character. Okay, so they have exactly the same length, and they must differ in at least one character. So how would you show that? So it reminds me of the proof of the complement of a to the n, b to the n, c to the n. The complement of that being context free, and the reason is that the number of a's and b's is different, or the number of a's and c's is different, or the number of b's and c's is different. And so that's kind of reminding me of that here. But it's just actually showing it, that's the troubling part. So I could enforce that all the strings are even just by intersecting it with a regular language, and that's easy. But it's just it's actually determining that they have where they have that different character and enforcing that it must be in exactly the same place. So they are differing in exactly the same place. Any of you have an idea? Yeah, because I thought that because you can kind of do something similar with an NFA in some sense. So you could try, if you have a string that's repeated twice in a regular language, then you could actually recognize just one of the two pieces. So if you had like WW being in the language, you could recognize all the strings of the form W. So just a single version of that. It's actually not an easy proof, but it can be done just by non-deterministic guessing. But what would you do here? So you would non-deterministically guess where the position is. Yeah, because I can't just push all the characters of X onto the stack and then just pop them off here because Y is not reversed. Yeah, that's not the same language. Yeah, the length is the same. Yeah, I'm not exactly sure about this one. I'm very confident that it is context free, but because it's related to the question of edit distance. So the question of edit distance is about how many edits, either deletions or additions or substitutions, you can make to transform one string into the other. And this is saying that the edit distance is at least one of the two strings. and we're not allowed to do deletions or additions. We can only do substitutions. So the edit distance, and so the number of substitutions is at least 1. So let's actually try to see. So if I have the string A, B, B, A, B, and then A, B, 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 A, let's say, for example, how would you recognize that this concatenation right here? What would you do? Yeah, so what would you do here? Because I can't just do S going to A, S, A, S like this, because these two S's could, like where the S part makes these other 4 characters, because it can freely do anything on both sides here because it's a context-free grammar. Okay, yeah, I'm not sure, in fact, about this one. But I am confident it is context-free. I just can't show it. I don't think my hole in the road would really help here for showing us not regular. But that wouldn't even help. Yeah, what would you do here? So x is not equal to y. Yes, they differ in 1 character at least. Yeah, to show that it's not regular, you would have to start with them being different and then end up with them being the same. Yeah, because the decomposition could have the middle piece of the 3 parts being of even length, so this condition might not ever be violated. It's this one you have to violate. So how would you formulate that? So if you had, so let's do a thought exercise. So if we had, yeah, so let's go back to what we had, these 2 pieces. So A, B, 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 A. Then let's say I can only pump in the yellow part, the orange part right here. Then yeah, it would have to really depend on the decomposition, I think. So if I put more B's in, okay, let's see. So if I had A to the P, B to the P, A to the P, B to the P minus 1. So this is just a thought exercise. Oh, that's it. Okay. Yeah, I figured it out. It is the P Factorial Trick. You do need it. Okay. I actually may have done this. Let me see if I've actually already done this. So P Factorial. I don't know what language I did. Okay, it's not exactly the same problem, but it is similar. Okay, so here's the trick. So the string that you actually have to pick here is this one. And you actually do need 2 different characters, A and B here, for this to even work at all. So what would you do here? So let's say that the decomposition has the length of y being not alpha, let's say beta. It's just some integer. Then what you do is x, y to the I, z is going to be a to the power p plus I minus 1 beta, b to the p, and then the rest of this is the same. So all you have to do here is to pick the value of I for which these two numbers are the same. So that's effectively saying that p plus I minus 1 beta is equal to p plus p factorial. Yeah, I think I remember seeing something like this. So this is equivalent to saying that I minus 1 beta is equal to p factorial. Then I is equal to 1 plus p factorial over beta. And this works. So this thing right here is an integer. And how do I know? Because beta is a number between 1 and p. And p factorial is the multiplication of all the numbers between 1 and p. So whatever beta is, it divides p factorial. So I here is actually an integer. So then you just pick the integer I such that this equation, that it has this value. And then what happens here is that the number of a's here becomes the same as the number of a's over here. And also what you do here is you also have to ensure here that we have to ensure that we satisfy this condition right here, that the length of the string is even. So we have to ensure that 4p plus p factorial is even, which works if p is at least 2. And so if p is at least 2, then we're all good. If p is equal to 1, then I can just pick any integer larger than 1 anyway. So here, as long as p is at least 2, it works. At least to get this condition. Yeah, so it's actually really tricky because you have to start off with two pieces that are different and then pump it enough, because this condition can still hold, pump it enough until these two parts are the same. And so we ensure that they're sufficiently different, ensure that it really is a member of the language. And then we pump up enough to where the number of a's here is the same, and we only can pump in this set of a's at the beginning anyway. So these runs of b's are never touched. And so they're kind of like separating each of the runs of a's here. And we just keep pumping up, and it works because p factorial divides every integer between 1 and p. And so that's the only way that this would even work, which is kind of slick. So it's not regular, but that still doesn't answer the question of whether it's context-free. Could you actually infer it from... Oh, you could almost infer the answer from the 4 given. Okay, so how would you actually show that it's context-free? Or show it isn't? Because it really is screaming to me that it is context-free, but I'm not exactly sure how to actually give a grammar for it. So if they're differing, yeah, all I have is a stack to play with, one single stack. I think I can do it with 2 stacks, but I can't do it with 1, which is kind of annoying. Any of you have any ideas about how to show this is context-free? I mean, if I went with my gut, I would say it's context-free, but I don't see immediately how to prove it. So what would a grammar for this look like? X is not equal to Y. So it's even length, because it can start and end with the same thing. So the starting and ending character have nothing to do with each other. In fact, they can be almost identical pieces, except that it can't be exactly the same. It must differ in at least one place. So it feels like I should use non-determinism to find that place. But how would you ensure that they're the same up to that point? There must be some trick that I'm not seeing. The length of x is not equal is equal to the length of y. Because I can't force that a variable used twice in a rule will generate the same thing. Because I can't enforce that. Yeah, I don't see how to do that. Let me look. No, it's a cop out, but yeah. So this one I don't actually know for sure. So this was 32. So okay, so this one is context free. Okay. So how would you actually solve that? So this is from 2019. Yeah, what would you... So that's not helpful. I mean, it very well could be that they gave the wrong answer, but yeah, I don't see how to formally prove that it's context free. I have a feeling that it is, but I don't immediately see how to prove it. It could be that the answer that they gave, or maybe that none of the answers is right. Actually, one of them has to be right, A or D in this case. I'm looking at the 4 possible answers here, but I don't know. I don't know how to show that directly, whether it's context free or not. I'm starting to get in the feeling that it isn't, and you actually might be right, Xshot, but that it's context sensitive and not context free. But I don't immediately know how to show. I don't know how to immediately show that it's not context free. All right. Any other questions you want me to botch? I don't see any in the chat, which might be a good or a bad thing. um, if there are no other questions, I'll wait like 30 seconds or so. there are no other questions, then we can call it for today. So thank you all for sticking around, watching me botch this question. Although there is a nice technique here for the P Factorial trick. I may do that in a video at some point, so that might be worth doing. Yeah, I'll look into this question to actually show why it's context-free or to show it isn't. So I'll look into that. So thank you all for joining. I will see you all next time. So keep on doing theory, keep supporting the channel. I really appreciate it.